I really shouldn't be here today. I'm living a life that I didn't think I would get to live. My doctors told me that I had one of the most aggressive versions of prostate cancer that they'd ever seen. I didn't think I would see my daughter actually get out of elementary school. I went through surgery, chemotherapy, radiation. It didn't work. So now I'm willing to go outside the lines. Science and technology have come together to help us understand that there are unique drivers of disease in our DNA. Turns out that genomic sequencing saved my life. But my cancer started growing again after 2 years. And so now I need to figure out how can I stop it? And those answers aren't crystal clear right now. My name is Bryce Olson, and I'm the global strategist for Intel's Health and Life Sciences Group. So the standard of care for advanced cancer is really kind of a cut, burn, poison approach, but everybody's disease is really unique. So we shouldn't be treating every individual the same. I think it's tragic today that 96% of cancer patients just go onto the standard of care, and when that stops working, they die. When I got diagnosed with stage 4 prostate cancer, the cancer had spread into other parts of my body. That is when it becomes extremely lethal and dangerous. I knew that Intel had this group that was helping the healthcare industry use technology to make cool transformations. And so I learned about work that we were doing with genomic research centers like the Broad Institute of MIT, Harvard. Intel works with the Broad to really help them accelerate biomedical discoveries.
So the first human genome took about 10 years to complete, and now we're doing it in about 2 days. And that cost went from several $1 billion down to around $1,000.
The whole workflow is underpinned by Intel technology. Disease can really be diagnosed in the DNA. Genomic sequencing represented a molecular diagnosis. So I went to my pathologist and I had 2 words for him. I just said, sequence me. In our DNA are 6 billion letters. These are essentially the genetic code that make us who we are. Genomic sequencing allows us to uncover that genetic code and also to look for mistakes and defects in it that could be the drivers of disease. What we found is that I had mutations in my DNA that were messed up and causing my cancer to grow. I used that data to find a phase 1 early drug trial that offered the opportunity to shut down those specific drivers of my disease. And it worked. It shut it down for 2 years. That's what precision medicine is really all about. The right drug for the right person at the right time.
Oh! You're not done yet! Wow.
No, I'm not done yet. I love being a dad, and the only reason why I'm getting to live that life is because of precision medicine.
Did you?
But it's not so easy anymore. I started to build up some resistance to that drug, and my cancer started growing again. So we're now going to try to discover things that no one else has figured out yet, really. So I assembled a cross-functional dream team of researchers that want to partner with patients on these type of research projects to push the envelope, really, on what's driving somebody's disease and then try to help figure out an exploratory way to treat it.
Wow.
The Broad Institute is one of the largest genome sequencing centers in the world. What we're doing is sequencing lots of people to try and understand the patterns of disease. Our genomic sequencers put out a huge amount of data. We manage about 70 petabytes of data. And to put that in perspective, if you look at every word in all of the books that have ever been written, it's still only about 50 petabytes. So we manage 20 petabytes more than that.
The problem is when you start amassing massive amounts of this data, there's things that we're gonna miss.
So Broad and Intel are working together to create AI and machine learning-based tools to analyze genomic data.
When Intel thinks about artificial intelligence, we really think about how artificial intelligence can crunch that data to find a unique insight.
AI can find patterns in data that the human eye can't see, that machines can find.
As we get better at that into the future, AI can help unlock those insights and make it more streamlined for patients to get the right therapy they need as quickly as possible.
And that's gonna help someone like me fight cancer and actually beat it in the long run. So you're gonna have to, I'm gonna hand you yours. The interesting thing is that, if it wasn't for Intel, I wouldn't be here talking to you right now because they opened my eyes to this new way to fight cancer. When you get diagnosed with something like this, you can do one of 2 things. You can either go into a deep, dark hole, or you can try to take the limited time that you have and try to make it as meaningful as possible. Intel's technology is underpinning a whole revolution in making these new discoveries to really power a new era of healthcare intelligence. It's going to enable pharmaceutical companies to discover the next drug that potentially might even be in the timeline that I need. For me specifically, I've got a recurrence. It's pretty aggressive, but I'm not really that worried because I know how to fight cancer differently. Every advanced cancer patient who is running out of options should demand genomic sequencing because genomic sequencing can open up the door to a new way to fight cancer, and nobody should give up hope.